Welcome to learning about accessible STEM documents. If you're not aware, STEM stands for Science, Technology, Engineering, and Math. And I'm going to show you what the difference is between an image PDF with STEM content, a text-based PDF with STEM content, and a Word document that has been marked up with MathML. Let's get started. First, I'm going to show you an image PDF. Most of you have run across this. It is simply an image of a file. In this example, I have a couple of pages from a single variable calculus book with a couple of images. There's a main section called 6.6 surface area, and then lots of math in the form of fractions as well as prose. Frankly, this file type is not helpful for anyone who might need an audio version or a file that is capable with a text-to-speech engine or a screen reader. Something that is one step above that is what is called a text-based PDF, which I have displayed on the right. It actually starts off as an image file in this example, but I'm going to use the built-in OCR software in Adobe Acrobat Pro to take this picture file and turn it into text. I'm going to do this by selecting Tools, Text Recognition, and then select the first option in this file. I can select all of my pages, hit OK, and now the computer is going in and it's assigning text to this image. Now that we've used Adobe Acrobat Pro's OCR engine to turn this image into text, we need to be skeptical about how the math turned out, as well as the other non-math text. So the easiest way to see what the computer interpreted is to highlight text from the PDF, copy it, and paste it into a new document. So I'm going to highlight question number 42, and as I highlight down, it's actually grabbing text from the question in the column to the left of it, question number 39 and even 40. This is an issue because this will not be clear to the end user which text belongs with which question. Nevertheless, for this demo, I will copy it and I will paste it into a Word document. The text that has been pasted, some of it looks good, some of it is really not good. The things that turned out well was the actual prose or the English. The things that didn't turn out so great was the math. It didn't capture all the variables properly, it didn't keep the fractions, it didn't keep the formattings. So this is essentially a hodgepodge of words and numbers and variables arranged in a very confusing manner. This document, as it stands, is not usable for someone who needs text-to-speech or who uses a screen reader. Now it's time to show you what an accessible, marked up Word document looks like. This Word document has basic accessibility features. If you're not familiar with the basic accessibility features of creating a Word document, please review my companion video. However, we're going to focus in on the math. Now, oftentimes when math is inserted into a Word document, it is inserted as an image. However, images of STEM content are not accessible. What we have done in this file is actually converted it using a special math OCR software called INFTY, where when the computer looks at the math page, it's going to translate the math and keep it as math instead of trying to turn it into English. You may notice that there's two different color boxes around the math. One color is a purple color. That indicates the equation came directly from INFTY and it came out perfectly the first time. The second color is a pink box, which indicates that it was an equation that was not quite converted correctly by INFTY and thus manually edited. As I scroll through this document, you can see that this document includes simple math from variables to longer equations, even fractions. Because the equations are marked up with MathML, this document is usable to someone who uses a text-to-speech software or a screen reader. For those of you who are unaware, MathML is a markup language designed for the web. MathML has also been designed to be accessible, where if a special text-to-speech or screen reading software came across this equation, it would read the math as math. You may be more familiar with something called LaTeX, or also pronounced as LaTeX. LaTeX is a typesetting language that has been around for decades and is often the language used when producing STEM content for journal articles. LaTeX in its form is not accessible. MathML is the best way to ensure accessibility for your STEM document. There's one more thing you need to know. PDFs currently do not support MathML, meaning that there is no way to make STEM content inside of a PDF accessible. What is recommended is to produce your content in a way that it can be easily turned into a different file type if needed for accessibility. If you must use LaTeX, please consider using MathType. MathType is a software that allows flexibility in turning LaTeX content into MathML content. We covered a lot of content in this video, and I would like to summarize. First, image PDFs are not accessible. Avoid images of mathematical expressions, as they cannot be read with adaptive technology. Text-based PDFs are not accessible because the math content will not be recognized as math. MathML is a markup language designed for the web. It will work with text-to-speech software and screen readers. LaTeX is a typesetting language used by the majority of STEM content creators. LaTeX is not designed to work with a text-to-speech software or screen readers. If you use LaTeX, the recommendation is to use MathType or a similar software that allows flexibility between turning LaTeX content into MathML. And as of November 2016, PDFs do not currently support MathML. Creating accessible PDFs that contain MathML is virtually not an option. The most accessible file type for STEM content would be a MathML marked up Word document or using MathML on your website.